And this is what we call an energy spectrum. Okay, an energy spectrum is essentially a plot of the observed wave frequencies plotted against the wave amplitude squared. The square of the wave amplitude is proportional to the wave energy, and the frequency is 2 pi over the wave period. Okay, because for a single wave, which only has one period and one amplitude, you get a single point in this diagram. But in reality, you have a variation of both frequency and energy, and you get a curve. Okay, and the curve has a maximum, and you also get a tail on this curve. Okay, and this is how you can characterize natural variations. Okay, let's have a look at it. Okay, let's see on the next slide. Well, okay, this is the energy spectrum for fully developed seas. Okay, so what we mean by that is you're in the open ocean and you have a wind condition over a long time, say several days, and you get a fully developed sea means that there is statistically no changes. Okay, you have the same average wave height. Okay? And then for these fully developed seas, you can show the energy spectrum as a function of the wind speed that you have. Again, this is shown in this little diagram here. So you have on the y-axis is wave energy in square meters. On the x-axis is the frequency in terms of how many cycles per second. In the bottom axis, but you can see at the top is also the period in seconds. Okay, and the different colors now correspond to different wind speeds in kilometers per hour. And I should also show you a little table of this one expressed in meters per second, whereby wind speeds exceeding 15 meters per second are rare. Okay, so we typically have more 10 meters per second is already a fairly strong wind. And what you can see here is that you get a specific maximum, a specific period of waves created by these winds. You know, a typical period is something, it's below 10 seconds per 10 seconds. You only get, if you have extremely strong winds, you get a longer period. Okay? And this is what we call as an energy spectrum. And you can actually use this to predict the sea state. Okay, if you know the wind speed, you can predict the equilibrium state of the fully developed sea. All right.